Hello, welcome everyone. I'm Sheikh Tipu Rahaman, working as an Aptitude trainer in Madanpally Institute of Technology and Science. So, our college, MITS, in accordance with AICTE, have started a scheme called Prerana scheme, where we'll be training students from SC/ST background to pursue or clear written exams of to pursue their higher education. So it can be for GATE or CAT or GMAT, GRE, whatever it is. Okay. So we are covering all the important topics, like common topics for all. So today's video we are going to discuss the most important topic, which is important for not only for upcoming future higher education exams, but for many government exams as well. Okay. So the title of the topic is data interpretation. So let's start our discussion. So data interpretation. What do you mean by data interpretation? When we break this two letters, like two words, data refers to information and interpretation refers to analyzing. So analyzing the given information is called data interpretation. And many people might be aware of this data interpretation concept topics is nothing but they'll be giving a chart or a graph or a diagram, and they'll be giving some values on it. So based on the given question, you have to analyze the given information and you have to come up with the answer. Okay. So in my sense, what I believe data interpretation is something humorous. So this is what I called data interpretation. So this is a famous serial, everybody is aware of it, CID. So kuch to gadbad hai. So that means something is wrong. So definitely there will be something wrong in the data, or to find some and analyze the given data. Okay. So just for fun, this slide. Okay. Now coming back to the real concept. So data interpretation, in order to learn data interpretation, DI, so these are the three important topics which are very important. As bat is very important for a batsman to bat, in the similar way, in order for you to solve problems on data interpretation, you have to be very good at averages, ratios, and percentages. Okay. So what do you mean by being good at average? And what do you mean by being good at ratios? And what do you mean by being good at percentage? So let us discuss those basic things first. Then we'll jump back to the different types of classifications or questions they ask for DA. Then we'll see some practice questions. Okay. So let us move on with the discussion. First, points to be remembered while solving data interpretation problems. So these are the important tips that you have to be aware of in order to solve data interpretation problems. So first, what is the first step? Increase your computational speed. In most of the exams, there will not be any calculators allowed. So you have to do it manually. And manual in the sense is better if you can get the answer without using pen and paper. There are few calculations that demand pen and paper, that is exceptional case. But the one which doesn't demand, it's very easy and it's up to you how you calculate it. Okay, so let us take this example. 1%, 2%, 5%, 10% of any number, say x. What does it mean? So let me take an example. In order to find percentage, for example, if I say what is 20% of 30? So 20% of 30, many people use the formula like 20 by 100 into 30. It's 100% correct, you can get the answer. But what if I ask what is 23% of 42? So again you'll end up with 23 by 100 into 42. So you'll end up with a 2-digit multiplication, which is little time consuming. I'm not saying it's tough, but it's time consuming. So how to get answers without actual 2-digit multiplications or 3-digit multiplication? So it's a very easy process. Let's discuss that. Now, in order to find any percentage of any value, you have to be clear with these percentages of that value. That means, let's say if I want to find 10% of any number, let's say, so what is 10% of 10? So 10% of 10 is, you divide 10 into 10 parts, one part will be 1. So let's say what is 10% of 5? Answer is 0.5. So if you want to calculate 10% of x, that means 10% of x. It is nothing but x by 10. So any values 10% is nothing but dividing that value by 10. So definitely 10% of 123 will be 123 by 10, that is nothing but 12.3. Similar way, 10% of 420 is nothing but 42. And for smaller values, 10% of 2 is nothing but 0.2. Clear? That is how you calculate 10%. Fine? Okay. Now, 10% is done. So how to calculate 5%? Let's say if a question is what is 5% of 5? So don't get stuck here. It's very easy. First calculate the 10% value of 5. Then divide by 2. Definitely you'll get on both the sides. You'll get 5% value. So let's see. It's very easy. So first 10% of 5, as we have discussed recently, it's 0.5. And dividing by 2 will give me the answer of 5%. 5% on both the sides. Dividing 2. So 0.25 is the answer. That's it. So if the question is what is 5% of 20, answer is 10% of 20 is 2. So 2 by 2, answer is 1. That's it. So 5% of 420, 10% value is 4.2, divide by 2, answer is 2.4. So I'm not doing any multiplication here, I'm just arriving to the correct answers. Clear? So that is about 10% and 5%. Now coming to 1%. So how do you calculate 1% of any value? 1% of x is nothing but 1 by 100 into x, that is equal to x by 100. Okay. Now 1% of 1 is nothing but 1 by 100. 1% of 10 is 10 by 100, that is 0.1. So if I ask what is 1% of 420, all you have to do is 420 by 100, answer is 4.2. That's it. It's very simple. Now, just in case if I want to learn 2%, how to calculate 2% of x? Very easy. First calculate 1% and multiply by 2, you'll get 2%. So the question is what is 2% of 20? So 1% of value, 20 value is 0.2, and 2% value will be 0.4, multiplying 2 on both the sides. Simple. So 2% of 420, 1% value is 4.2 into 2 will give me 2% value, that is 8.4. That's it. Clear? So this is how you calculate 1%, 2%, 5% and 10%. Now we'll go to some practical problems. If you know these four values, how can you get percentage of any value? Let's say if the question is what is 98% of 22. I know normal will take time, but it's easy, but you have to do multiplication. But first, what is 100% of 22? 100% of any number is the same number. So what is 1% of 22? 0.22. So what is 2%? 0.44. So all you have to do is subtract these two values. 100 minus 2% is 98%, and 22.00 minus 0.44. So this will become 10 minus 4 is 6, 9 minus 4 is 5. Answer is 21.56. That is 96% value. Clear? 22% of 43. So it's all easy. First find 10% value, 4.3. 20% value, 8.6. 1% value, 0.43. And I need a 2% value, 0.86. So 20 plus 2, 8.6 plus 0.86, 6, 9.46 is the answer. Simple, right? It's very easy. The more you practice this kind of stuff, the easier it gets. Okay, so this in turn helps you to increase your computational speed. Okay, this is the first important basic point that you have to learn in order to start solving questions from data interpretation. And data interpretation, that is DI, is a very important topic in most of the company specific private exams as well as government exams. To get jobs, or to continue further studies as an entrance exam topic. Clear? So this is the first thing. Now, so that is how you increase your computational speed. Second point, you have to be able to calculate average of 6 3-digit numbers in less than 30 seconds. So we know the concept of average is total number of sum of observations by number of observations, and always we go with approximations, because in the option list, if the options are not very much near to each other, we can approximately do that, but if they are very near the other option, you have to do exact calculation. So what am I talking about? It's very easy. What I have to do, there are 1 2 3 4 5 6 3-digit numbers. I have to add everything and I have to divide with 6, then only I'll get the answer. But again, adding this and dividing will give me some what you call time consuming answer. So what I have to do is take the nearest number, 200, 150, I can take it as 700, 900, 350, 750. Now add 200 plus 150, it's 350, 350 plus 700, it's 1050, plus 900, it's 1950, plus 350, it's 2300, plus 750, 3050, and you have to divide this value with 6. Getting my point? So answer will be 6 5s are 30, and 6 are 36, 6 8s are okay, somewhere around 508 or 505 you'll get. But when you do exact one, you'll be getting the value around this. So what I'm trying to say is, if you do this, it can be done in less than 30 seconds. But if you're going for exact calculation, it all depends on the options they'll ask. Okay, so it's very easy to do, no need to hesitate and no need to worry. So this is how you increase your computational speed, by doing average in less than prescribed time. Okay, this is related to percentage, this is related to average. So coming back to the previous slide, so average, percentages, now we understood what is the importance. So ratios is something that is nothing but taking the numerator antecedent with the consequent new denominator. So ratios are also easy, and I can take example which are in upcoming slides. Okay, so these three are very important basics to learn and practice and crack DI in many exams. Clear? Okay. Now, few more important tips while you start solving data imputation. So in data imputation, there will be some charts given. It might be some graphical representation, pie charts, whatever it is. In those charts, many people, what they do, they usually neglect units, because units are something that definitely gives you correct answer. If you don't conclude or don't consider units in the calculation part, you might end up with wrong answer. And people who set the question paper, they know what are the common mistakes done by students who are writing this exam. So you can find even your wrong answer in the list. So ensure that you are very clear about the units which are important for calculation. Clear? And next, this is the first point. So next point is, don't neglect footnotes. Important details may be given on it. Any diagram you see, on the top or on the bottom, with small fonts like small letters, letters in the sense like not usual but smaller than the usual one, there will be written some information. That information is called footnotes. So footnotes can be entered below the diagram or above the diagram, or sometimes right or left, doesn't matter. So if you don't consider these footnotes, again you'll end up with wrong answers. So all the important details will be considered here. That one of the important detail will be also units. Okay, that is second important. And third one, before proceeding to start practicing, you have to understand percentages. And in this previous slide, we have very well understood percentages, how to calculate any percentage value into anything. Clear? That is about few more basics of attention details that has to be given to solve or crack DA. Okay, now, so this is your first example for this session. So if you see, there's a diagram here. and there is a title given, profit of a vaporware private limited in the last 2 years in rupees crores. So it is a footnote for this, we can say as heading here in this case. So there's the year here. In the year 1996, profit was 120. What 120? Crores. In the year 1997, profit was 150 crores. Now there are 5 different examples to illustrate how this simple diagram can be asked in many ways. Like what are the questions they extract from here? So what I would suggest my audience, those who are watching this video, please pause this video for a while and try to answer these questions for some time. I'll damn sure that definitely you'll end up with correct answers. But few people will get confused because few questions look similar, or you can get this answer to that or that answer to this. That's quite common. But I would suggest you please do that. So once it is done, if you get the answer correctly, just verify it. If you are like getting like tricky answers, or if you are confused, no worries. You can resume this video and watch. Okay. Now, first question. Profit increased from 96 to 1997. So 1996 the profit was 120 crores. In 1997 it is 150 crores. How much did the profit increase? So 150 minus 120. Answer is 30 crores. That is the answer. Clear? So profit increase is 30 crores. That is first point. Second point. Profit in 1997 was how many times the profit in 1996? So they're asking 1997 profit was how many, that is x times of 1996. When you start converting the given question in terms of equations like this, it will be very easy for you without any confusion. So 1997 was how many times the profit of 1996? So 1997, what is the value? It's 150 equals x into 1996, 120. So x value will be, this is 3 4s, the 3 5s. So it is 5 by 4. Simple. If they want you to convert into what you call decimal point, so it's 1.4125. That's it. So 150 is 1.25 times of 120. It's clear. Clear? So that is second question. So third question, profit in 1996 was how many times the profit in 1997? So don't worry much, just write down the equation. 1996 was, is nothing but equals how many times the profit of 1997? Simple. So 1996 value is 120 crores is x times of 150 crores. So x value is 120 by 150 this time, that is 4 by 5. X is 4 by 5, that is nothing but 0.8 times. So 120 is 0.8 times of 150, that is the meaning. So hope there is no issue in understanding these 3 questions. Clear? Now let us come to the fourth one. So let me erase this ink for a while so that I'll get more clarity on solving. So 1 2 3 order. Fourth one. Profit earned in 1997 was what percent more than the profit earned in 1996? This is the most important type of question that you might come across in almost most of the questions from DA. What they are asking? They are asking the value increased from one point to another point with respect to percentage. That is very important. So profit earned in 1997 was what percent more than the profit earned in 1996? So let me take an example. Let's say x is a value here and it is being increased to y. Okay. So this is the axis, x to y, it has gone up. If I want to see how much the value has increased with respect to percentage, okay, so how much x to y with respect to percentage, what you have to do is difference you have to take with respect to x, percentage into 100. Sometimes you ask what increment from y to x, then you have to take difference with respect to y into 100. So you have to be smart enough because numerator will be same but denominator differs based on the question they ask. So be smart enough, know which answer you put, because if answer comes with X and if you put Y, but in the option list you can find both the options, so you again end up with wrong answers. So that is what I would suggest. Clear? Now, profit earned in 1997 was what percent more than the profit earned in 1996? So what I have to do, first step is difference, 150 minus 120 by, now what is my base? Is it 96 or 97? Profit earned in 1997 was what percent more than the profit earned in 1996? So I'm comparing 97's profit with respect to 96 years profit. So 96 is 120 into 100. That's it. So difference is 30 by 120 into 100. So 3 ones are 3 fours are. So answer is 25%. So whatever profit I got in 1997, with respect to 1996 is 25% more. That's the meaning of it. Okay. So from 96, my chart has grown 25% more in 1997. If you are clear with this, definitely there will not be any confusion in most of the problems on DI. Okay. So next question, similar one with little change. Profit earned in 1996 was what percent less than the profit earned in 1997? So as I said, numerator doesn't change, it has to be the difference. 150 minus 120 by, what is my reference now? 1996, what was percent less than the profit earned in 1997? So answer is denominator 150 into 100. So it is 30 by 150 into 100. So 1s are 5s are. So answer is 20% less. Whatever I got in 97, 96%, the year 96, the profit was 20% less. Clear? So take time to understand, analyze this. But still, if you have any doubts in this slide or any slide, you can always comment. I'll try to respond at the earliest. Clear? Okay. So that's the thing. Next. So let us see one more example which helps you to give a clear picture of sense of approximation. You have to develop sense of approximation. Okay. So as we have discussed in the first slide, averages include sense of approximation, percentages you can easily calculate, ratios is what we have discussed in the previous slide, this one. These all are ratios, numerator by denominator. So this is also one of the example of DI where all three things will be used, ratios, percentages and ratios and percentages will be used. Okay, and averages. Sorry. So this is an example, just have a look for a while. There's a table, data given. So if you observe this, there are no footnotes. Okay, RVG hospital is given, PKR, JP hospital. So TB, tuberculosis disease, 123, 201, 168. AIDS, they are given some values, leukemia, laryngitis, neurosis. So they have given 5 different diseases and their cases, number of cases in 3 different hospitals. Okay. Now, first question. The average number of TB patients in the 3 institutes is nearly dash. So TB in 3 institutes. So 123, 201, 68. So as we have discussed, when you have to find the average, it's better if you approximate to the nearest round figure of 10. So I can write as 120, 200 and 70. 120 plus 200 is 320, 320 plus 70 is 390. 390 by 3, because there are 3 entities, I'll get 130. Whatever is nearer to 130, that is the answer. So if you see option C, 131 is nearer to it. But when you take your calculator and do exact calculation, definitely you'll get 130. But in the options, if you have 130, 129, 132, I would not recommend this method for you. You have to do it exact calculation. Because options are little far to each other, this sense of approximation have really helped you to get the answer. Are we clear with this? Fine. So let us see one more example for this data table. Second example. So what does this example says? The RBG hospital has what percent less patients in AIDS than those of PKR clinic? So here they are trying to compare two values with respect to percentage. So in the previous concept we already discussed, when you compare two values with respect to percentage, you have to take the difference with respect to what common base or what value you are comparing into 100, because percentage is with respect to 100. Clear? So let us see this. RGV, they want the value of AIDS 41 and PKR clinic 2061. Now read it again. RGV hospital has what percent less patient in AIDS than those of PKR clinic? Now what I have to do? Take the difference, 61 minus 41 divided with what value? PKR clinic they are asking, so 61 into 100. So this is nothing but 20 by 61 into 100. So if I approximately take it as 60, 1 za 3 za, answer is 33.33%. So denominator I have decreased, so numerator will increase. Whatever is the answer to me will be less than 33.33 but nearer to it. See, from 61 I made it to 60. When I decrease the denominator, the numerator value, whatever answer I got, will be more than the actual value. So the answer should be 33.33 less than 33.33 but near to it. If you see the options, I can exclude 34 and 35, 32 and 30. Whichever is near to 33, that is the answer. But if again you have 32.6898, then you have to do exact calculation. So for this question, the answer is 32.78, approximately 33%. Is that clear? So this is how you approximate by implementing sense of approximation. Okay. Now let's move on. What are the different types of charts or questions they'll ask in data interpretation? Okay. So these are the different types of questions in appear in four different formats. So it is mentioned four, but I would like to add one more later. No need to worry. So first one is a bar graph. Okay, we'll discuss everything one by one. So bar graph is nothing but there'll be column charts. We call it as column charts or row charts. Okay. So where these are the given figures and they'll be asking questions based on that. Okay. So pie chart where everything is like a circle and it is being divided based on the given data and they'll be asking questions on it. So table chart, as you have seen in the previous diagram, there'll be table given with the relevant data and you have to extract information on it. So line chart is similar to like column chart where you can't see any connection to the x-axis, so it will be only flying like this. Okay. So any information can be represented in all this format. Okay. So we have some examples like that, so no need to worry. And there is one more category, fifth category, call it as mixed chart. Very rarely they'll ask, but I think everybody will be familiar with this. So mixed chart is nothing but combining any two or more charts. If you see in the newspaper, they'll be having Sensex with a line chart here and there'll be column chart, that is bar chart here. Okay, so combination of two or more charts is called mixed chart. Very rarely they'll ask, but it's better to know and have the information with you. Clear this? Okay, fine. So these are the different basics we have discussed. Now let us discuss what are the different types of chart with relevant examples. Okay. Now, first one. Under the bar chart, we have again different categories of chart. The first is simple bar chart. So a simple bar chart is nothing but the representation of different values on x-axis and y-axis. If I illustrate an example, you'll get more good picture. Let's say there is a college called X. Okay, and each year, let's say this x-axis is a year 2001, 2002, 2003, and 2004. So each year, this graph represents the number of students joined in the college. Okay, so in 2001, let's say y-axis represent in thousands. Okay, this is years. So in 2001, approximately 4,200 students joined. So 2002, 2,500. 2003 3,500, and 2004 like 4,500 something. Okay, so if you assume these estimations or examples, you'll have a very clear and clear cut idea how to understand this simple bar chart. Okay, but still the simple bar chart has limitations. Let's say in each year I want to know how many ECE, triple E, and mechanical students are joining. So can I use this chart? Definitely not, because it gives a single information. Then the drawback of this is overcome by one more category of bar chart. It is called as composite bar chart. So in composite bar chart, a single category is again subdivided to multiple subcategories. So it can be 3, 1, 2, whatever it is, more than this. Okay. So same example I'll consider. So let's say these are years. So 2001, year 2, whatever is 2003, 2004, 2005. And these are the y-axis in thousands. Now here I can represent how many EC students have joined, triple E students have joined, mechanical students have joined. So same thing applies. So I'll name it this A as ECE, B as triple E, and C as mechanical. Okay. Now you are free to mark or increase or decrease the value based on your input data. So from this, it's a clear-cut information that EC like around 4,200 has joined in the year 2001. If somebody has, how about 2004? How many mechanical have joined? Sorry, how many mechanical have joined? I can easily show this and I can point it. Yeah. So this is about composite bar chart. So there are further few more types of bar charts we'll discuss. So this is one of the bar chart where rarely comes into picture in the problems. It is deviation through bar chart. So best example illustrates is in business. In business, we not only have profits every time, we do have loss as well. So to include a simple bar chart with negative x-axis is nothing but deviation through bar chart. That's it. So profits as well as loss can be mentioned in this term. So if you see till category 4, all are positive values, 5, 6, 7 have negative values. Clear? So next. So this is a more effective type of bar chart. We call it as percentage on a stacked bar chart. Now whenever you see these kind of charts, every category will be compared with 100%. Okay, but this value of A and this value of A will not be same. It will be definitely different. If I explain you here in this slide, it's a very likely that most people will not understand. So percentage of stacked bar chart, we have a perfect example where you get more clarity to understand this kind of question. Okay, so we'll be discussing that there, that too in this video. No need to worry. Okay, good. Let us jump to the one of the best like simple example, and we'll discuss what are the types of questions they'll ask in bar charts. Okay, now if you see this diagram illustrate a bar chart. So to be precise, a composite bar chart where exports and imports of a country is given in 1,000 crores. Okay, so x-axis are nothing but the years and y-axis are the money, that is currencies in 1,000 crores. So where A is this blue color is exports and B is import value. Now, so the question in 1994, what was the export of A? So in 1994, A has exported 80,000 crore value worth money. Okay. Now, what are different possible questions they'll ask? So different possible is uh, total exports from 94 to 99. So only thing you have to do is you add all the blue color. That's it. And how to add 80, 130, 140. Instead of 112, take 110. A sense of approximation. Then 170, 160. That's it. Similarly, imports. So that red color, maroon red. 70, 120, 150, 100, 160, 150. That is the first type of question they might ask. Second is, what is the average export during this tenure? What you have to do is you have to add 1, 2, 3, 4, 5, 6 values. Okay, divide by 6. That's it. That sum you have to do and divide by 6. The same procedure is applicable for imports as well. It's easy, it's not complicated. Clear? So that is how they'll ask average imports or export. That is second type of question. Now, third type of question. From year 94 to 95, what is the percent growth in imports? That's it. That's the question. In the year 94 to 96, what is the percentage growth of imports? So what you have to do is from 70, import is right, to 120. How much that has grown percentage wise? So what you have to do is 120 minus 70 by, with what we have to compare? 70 only, right? So 70 into 100. So 50 by 70 into 100 is the answer. So 5 by 7 into 100. 500 by 7. So based on the options, if they ask for mixed fraction, you convert into mixed fraction, decimal, you convert into decimal. It's not a big deal. Clear? So here if they see what is the percentage decline from 96 to 97 in exports. So what you have to do is 140 minus 112. You take 110 for your convenience, divided by 140 into 100. That's it. So difference by the base value into 100 will give the answer. Clear? Okay, that's the example. So this is one more example illustrating a simple bar chart. Okay, where it looks very simple. The only thing is the values are in 4 digits. So the possible questions they might ask is simply they'll ask you to find the average from 91, 92 to 98, 99. What you have to do is last 2 digits consider as 0, sense of approximation to get the answer. So 2600 plus 3700, 2500 and so on. 1, 2, 3, 4, 5, 6, 7, 8. Add everything and divide with 8, you'll get the answer. That is one type of question. Second type of question is what is the average increment from this value to this value? So difference by this value into 100. Okay. The more questions you practice, the more idea you get what type of question they'll ask. I'm just clearing the picture for you. I'm directly asking simple questions, but questions also they'll twist a little bit so that you have to involve in it to understand what they're asking. As the time is constrained and limited, I want to cover all the charts. I'm just explaining by myself, but I would suggest definitely see some practice questions and see how they are asking to get a clear picture of it. Okay, good. Now, so as I promised, this is a wonderful example illustrating percentage stack bar chart. Okay, so let us discuss this. So answer the questions based on the chart below. The bar chart given below shows a percentage distribution of the total production of cars manufacturing company into various models over 2 years. Okay. Now, as I said, everything in this stack chart is compared to 100%. Now study this for a while. We do have footnotes here as well as here. Percentage of 6 different types of cars manufactured by company over 2 years. What are those? In the year 2000 and the year 2001. Total number of cars produced in the year 2000 is 3,50,000. Whereas total number of cars produced in the year 2001 is 4,40,000. Okay. Now, what are the questions they'll ask? Simple question. Number of P-type cars produced in the year 2000. So what is the answer? So answer is 30% of total value, 3,50,000. So as I said, 10%, it's very easy, 35,000. So 35k into 3, that's it. 1 lakh 5,000 is the answer. Clear? Simple. So same thing applies for 2001 as well. If they ask P type, it is 40% of 4 lakh 40,000 value. Simple, right? Yes, it is. Okay, fine. So next category of question. What is the percent growth in production of cars from 2000 to 2001? Production of total cars. That's the question. So what would be the answer? From 350 it has gone to 440. Sorry, that's it. 3,50,000 it has gone to 4,40,000. They're asking with respect to percentage. So what you have to do is you have to take the difference. Okay. So 4,40,000 minus 3,50,000 divided by the base value is this, obviously 3,50,000 into 100. So all three zeros will be cancelled. Okay, four zeros will be gone. So I will be left out with 44 minus 35 by 35 into 100. Okay. So 44 minus 35 is nothing but 11 by 35 into 100. So do this calculation, you end up with correct answer. Not a big deal. Okay. Now, one more type of question they'll ask is simple. What is the total number of cars they produce of S and R category in the year 2000? So what you have to do is, so total how much percentage? So 1, 2, 3. 30% of this value, 3,50,000. Again 1,05,000 I'll get. Clear? So R categories there are 20%, whereas S is 10%. That's it. Clear? Okay. Next, last question. What is the percentage change in production of S type of cars from 2000 to year 2001? So many people commonly do this mistake. They'll see S is 10% here. Here also is 10%. So 10 minus 10 is 0. No, that's wrong. So 10% of what? This is what it is important. So it is 10% of 4,40,000 minus 10% of 3,50,000 divided by 10% of 3,50,000 into 100. Clear? So as we have done earlier, same method, all 10% zeros will get cancelled. You can easily get the answer. Okay. So this is about percentage stack bar chart. Okay. Now this is a similar example in the composite bar chart that we have discussed. Okay. Now second category. What is this? Pie charts. So in pie chart, it's a circle. This circle has 360 degrees and it is equivalent to 100%. So that means finally I can conclude this 360 degrees 100%. So 1 degree will be 100 by 360 percentage. Similarly, from here 1% will be how much? 360 by 100 degrees. Simple. Clear? Now let's say in the chart there are k degrees are given. Okay. So how do you convert the k degrees into percentage? So k degrees, or let's say x degrees, whatever it is. So x by 360 into 100. This formula will make, it's not a formula, it's a procedure, that's it. So 1 degree 100 by 360. X degree, it's a 100 by 360 into x. Similarly, If X percentage is given, or let's say Y percentage, how do you convert into degrees? Simple. So Y by 100 into 360. Simple. So we have any examples in this slide. I'll be restricting myself to discuss few examples so that I'll cover up main all the things. Then we can in the upcoming sessions we can discuss the questions. Okay. So major thing is this. This is what it's important. So total angle is 360. K percent is K by 100 into 360. 1% is 1 by 100 into 360. M degrees is same thing. Same thing I have written here. So it's very easy. Okay. So these are different questions. I'll leave it myself. Okay. Let me discuss this question. The various sections of the population are indicated below in the pie chart. Study the pie chart and answer the following questions. The total population of a city is 5,000. Total population of a city is 5,000. And these are the different values given with respect to degrees. Now, they represent this. So let's say 5 is unemployed. Unemployed is 18 degrees. Now the question they'll ask is, tell me how many number of people are unemployed in this city. So how to do is 18 by number. So it's in 360 into, if I ask percent, I have to multiply 100, but they have given the value, so into 500. 5,000, that is the answer. Simple. Clear? Now if I want to know how much percentage of self-employed people are there in the city, so what I have to do? Fourth category, it's again 18. So 18 by 360, this time I'm asking percentage, so into 100. So whatever question they ask, you have to simply change based on the requirement. Clear? So you can refer many questions. These are the basics, helps you to solve the problem. Fine. So all the same questions. Okay. Next, third category. Sorry if I'm skipping the questions because the intention of this session is to introduce you with different types of charts they'll ask for the data interpretation concept. Okay. Upcoming sessions will have the video on different questions. Don't need to worry. Okay. Now, see this question for a while. Category of assistance, average number receiving per month, total cost per help year, cost paid by the center. Okay. So let me keep this question. I want to discuss you with simple examples. Okay. I'll start with this example. This is very simple for your understanding. Then we'll have the questions on it. No need to worry. The following table shows the number of new employees added to different categories of employees in a company and also the number of employees from these categories who left the company every year since the foundation of the company in 1995. So this description is the number of a company was started in 1995. Then every year the number of employees of each profession is been joining and leaving. Okay. Now in the year 1995, how many managers were there? 760. Now, can you tell me in the year 1996 how many managers were working? The answer is not 280. It is initially 760 plus 280 and 120 left. That is the answer. That's it. 760 plus 280 minus 120 is the answer. In the similar way, if I ask how many accountants were working in the year 2000, what you have to do, you have to add everything. This you have to add. Let's say this value is x, this value is y, and finally you have to subtract. X minus y will give the answer of number of accountants working in the year 2000. Okay, all you need to do is addition and subtraction for this type of example. Okay, hope you got a clear cut picture. Similarly, in 1996, how many peons were there in that college or organization? 820 plus 184 minus 96. That's it, simple. All additions. So easily you can come up with that. Clear with this? Good. So one more example to give more clarity on table chart. So if you see, the following chart is a record of performance of baseball team for first 7 weeks of the session. So first week, second week, third week, fourth week, fifth week, sixth week, seventh week. So first week, 5 they have won, 3 they have lost. So cumulative means you have to continuously add one by one. So 8. So 4, 4, and total in the first 2 weeks they have played 16 games. So 5 won, 5 lost, 2 lost. This is the given data. Now what is the question they'll ask is, what is the winning percentage? Winning percentage is total 50 games are played, out of which how many they have won. So let's say this value is x. So x by 50 into 100 is the answer. That's it. Losing percentage is this. Now sometimes they'll ask in which game winning percentage is more, in which week winning percentage is more than losing percentage. So if you see, what you have to do is 5 minus 3, or if I say this difference by 5 into 100. This will give my winning percentage for that particular thing. Sorry, I would excuse myself. This is wrong. So our first week they have played 8 games. Out of 8, 5 they have won. So 5 by 8 into 100 is the answer. This is winning percentage of first week. So losing percentage is 3 by, how I got 8 is 5 plus 3, add total number of games into 100. So for sixth week, what is the winning and losing percentage? Simple, 3 by 3 plus 3, 6 into 100. If I see 3 won, 3 lost, so it is 50%, 50%. Clear? So this is how questions are asked on the different types. That is about table chart. So the last category is line chart. Okay. Now let us see this example, and after this one more if time permits, then we'll wind up the session. In the upcoming sessions, we'll jump into clear-cut questions, how to solve and analyze this. So intention of this class is just to brush up you, introduce you what type of questions they'll ask. Okay. So study the following line graph, which gives the number of students who joined and left the school in the beginning of the year for 6 years, from 96 to 2001. Okay. Initial strength of the school in 1995 was 3000. This is one of the footnote. Next, number of students is given in the y-axis, year is given the x-axis. So I can see some red and blue color line. What does it represent? Again, there is one more footnote here. Red means number of school students who joined. B means number of school students who left the school. Now, can you tell me how many students were present in the year 1996? So people will just compare this one. So 250 is the value, 350 is the value, 250 minus 350, or 350 was 250 they'll do. But that is not the actual procedure. The base value is 3000, initial strength was 3000. Then how many red color, right? Red color how many joined? 350, that is plus. And how many left? 250 left. So the final count is 3100. That's it. Understood my point? So it's all like similar to tabular chart. Okay. So there the information is given in tabular columns. The same thing is given in lines. That's it. Connecting points. So if they ask how many students, number of students were present or were in the year 2001, what you have to do is you have to take the initial value 300, 3000 and add all the red values with that. Let's say the sum of this value is x. So 3000 plus x you have to do. You'll get some answer. Then whatever you get the sum, you have to again add these values. 1, 2, 3 blue values. Let's say the answer is y. You have to subtract. That's it. Sum minus y will give the answer. Getting my point? Add all the connecting points, you'll end up with the correct answer. 3000 plus all red points minus of sum of all blue points. This will give the final count of students in the year 2001. And these are the kinds of questions they'll ask, but not in the simpler language what I'm asking. So if you have a clear picture with the basics, we can directly jump into the practice session. Clear? So one more last example for the day. This is the example. In a school, the periodical examination are held every second month. In a session during April 2001, March 2002, a student of class 9 appeared for each of the periodical exam. The aggregate marks obtained by him in each periodical are represented in the line graph below. Okay, so it is the given data before the chart. So marks obtained by a student in 6 periodical held in every 2 months duration in the year session 2001 to 2002. Maximum total marks in each periodical exam is 500. Okay. Now, by seeing this picture, I can see there is a growth from April 1 to February. So 1, 2, 3, 4, 5, 6. So total 6 exams have been held. That's what they have mentioned. And these are the marks. Okay. Maximum marks is 500, but this person was able to score only 405, so they have not given 500 here. And this is the period, that is from April to March. Now, what are the questions they'll ask here? They'll ask from April to February, what is the total growth of the aggregate percentage, or what is the improvement? So what you have to do is 405 minus 360 by 360 into 100. So from 360 he has improved to 405. So what you have to do, difference by 360 into 100 will give the answer in percentage. Okay. Or they can ask consecutively. So from June 1st to August 1st, what is the improvement score of his marks with respect to percentage? So difference 370 minus 365 divided by 365 into 100 will give the answer. That's it. Okay. Now one more question they'll ask is, what is his average score during this 6 periodical held exams? So 360 plus 365 plus 370 plus 385 plus 400 plus 405 divided by 6 is the answer. 1, 2, 3, 4, 5, 6 values. Clear? So this is it. And if they ask mixed chart, obviously they'll be like with column bar charts, that is bars. So that's not a big deal. Okay. So that is for the day. So let's just have a small revision of it. So we started our discussion with data interpretation. Okay. Then we have discussed what are the basic things which are important for DI. So as I have said, averages, ratios, and percentages does matters for them. And then we have discussed how to increase your computational speed by learning percentage first. So percentage of any number can be learned by can be calculated by knowing 10% value. So from 10%, if you divide by 2, I'll get 5% value. So 10% of x is x by 10, by 2 will give 5%. Similarly, 1% of any value can be denoted as x by 100. 1% of x is x by 100, and if you multiply with 2, I'll get 2% value. After that, we discussed how to calculate the average of 6 digit numbers in less than 30 seconds by developing approximation sets, that is round figuring it. So nearest 10th I have round figured, and I was easily able to calculate the average, nearest average, not the exact value, with out using calculator. Clear? Okay. So then we have discussed a few more important things which are important for proceeding to learn DI on how to crack. So units are very important. We have seen the different units for different diagrams, charts, and then footnotes also contains important details. That's what we have seen, and we also understood percentage importance. So this is the first example we have learned. Okay. So different example to illustrate on different aspects of ratios, percentages, and averages. Then we have discussed one more example to develop sense of approximation. And finally, we have discussed this one. So bar chart, pie chart, table chart, and line chart. So bar chart is called column chart, whereas pie chart we have a circle which is divided into different categories. Table chart has tabular columns, and line chart the same type of information represented by connecting dots. Okay. Then bar chart, the first one is simple bar chart. Then so it does has limitations, what we have seen here with this example. So to overcome again the subcategory of each category, we can see it in composite bar chart, and doesn't have a limit, so you can subcategorize it into more than 2 till any number based on your visualization. Then so very rare case they'll ask where we can see even negative values for a simple bar chart. It is called deviation through bar charts. Okay, so it will be very helpful in the application of denoting any loss of a company or something. Next, followed by percentage bar stack. So we discussed this with an example, so hope it got a better understanding for it. So these are the examples we have discussed. So this is where we have discussed the percentage bar chart. Then we have discussed what are about major properties of pie chart. So where circle is 360 is compared to 100%. From here just you can say 1 degree is this, 1% is this. So if you get x degrees, how to convert it to percentage, percentage, how to convert into degrees. So this is what we have derived. Then we have discussed one example. Okay, to find number of unemployed people, I'll get 18 by 360 into 5000. So one percentage 18 by 360 into 100 will give me the percentage value. Then we have discussed tabular column. Tabular column we have discussed the example, followed by one more example. Then finally we have discussed line chart. Okay. So hope my session was helpful for you people. Still, if you find any information is much needed or any corrections to be included, I'm happy to welcome comments for my video. Okay. So I would really thank you for your patience. Thank you so much. See you in the next video. Thank you.